The video for class 12th, and that topic which we are going to deal is the introduction to the Faraday's laws and Henry's experiment and their observation, and how the Faraday has introduced its own law. So this is the video number 2, okay, lecture number 2, which is based on the chapter electromagnetic induction. So first, what the till now what we have understood, we have understood that electromagnetic induction or EMF can be produced, or the current can be produced by changing the strength or by changing the orientation of the magnetic field lines. Secondly, what Henry and Faraday's has done, they have taken magnetic field which is going inside to the copy, means which is perpendicular but downward, okay. And what they have taken, they have taken a closed loop, okay. This I current I have drawn, the diagram direction of the current I have drawn randomly, I have drawn, it is not very sure that it is very correct or not, but we have taken a loop, closed loop. Now what they have done, they are changing, keep on changing the magnetic field strength across this area. Now what is happening after this, when the flux, because magnetic field lines are changing through this unit cross sectional area, what they have observed, the current is induced in the coil. And till when this process will be happening, or till when this process will be continuous, still the B is changing. Means if you will keep on changing the magnetic field line, there will be a keep on production of induced current. And if you will stop the change in the magnetic field lines, the production of induced current will also stop. Second, in the second diagram, what they are doing, they are not changing the magnetic field strength, but in spite of that, they are changing the area of the coil. Means they can increase the area of the coil, they can decrease the area of the coil. The magnetic field line direction is kept same. Now what we have done, we have kept the B constant, means in spite of direction, they have kept the magnitude as well as constant. Again, what they observe, a current is induced in the coil. Until when the current will be induced, till you will continue or you will keep on doing this change. Third, what they have done, they have kept the magnetic field line constant as well as they have kept the area constant. Now what they are doing, they are rotating the conducting coil, means they are rotating the conducting coil, or they are changing the direction or the angle between the magnetic field line and the area vector. So what they are getting, they are getting again the current is induced in the coil. So in short, if I want to write down the statement about these three experiments, what I can write down, if magnetic flux is changing, the induced current is also changing. If you will change the magnetic flux in either of the way, if either by changing the magnetic field lines or either by changing the area or by changing the orientation, you will get a change in the induced current. Means after this experiment, Faraday has observed and he has given its own law. The first law what he has given, whenever the amount of magnetic flux linked with the circuit changes, an EMF is induced in the circuit. Simple. If a flux is changing, an EMF is induced. So the induced EMF lasts so long as the change in the magnetic flux continues. I guess I have explained you कि जब तक जिस वजह से मैग्नेटिक फ्लक्स हो रहा है या जिस वजह से EMF इंड्यूस हुआ है, वो वजह जब तक रहेगी सर्किट में, तब तक हमारा EMF इंड्यूस होता रहेगा. And if the moment the change because of which EMF is happening, the change will stop, the production or the induction of the EMF will also stop. One more thing he has told, if the conductor forms a closed coil or forms a closed circuit, the induced current flows through it. Means if the circuit is closed, whatever the circuit we are talking about or whatever the circuit we are taking, if that circuit is closed, the current will be induced. So second, how they have performed or how they have told this thing, they have taken they have taken a coil and they have connected the terminal end with the galvanometer. Now what they have observed, they have kept a magnetic bar magnet around it, and what they are doing the relative motion between the magnet and the coil. First they are decreasing the distance between a coil and a magnet, and then afterward they are increasing, means they are doing a relative motion. So by doing a relative motion, what we can say, whenever there is a relative motion between a coil and the magnet, an EMF is induced by the coil or a conducting coil. Okay. So this was done by Faraday and very beautifully explained. The second law, what he has observed, the magnitude of the induced EMF in a circuit is actually directly proportional to the rate of change of magnetic flux linked with the circuit. Means what? We know that the EMF is induced because of the change in the magnetic flux, and if till the magnetic flux change will be there, the induction of the EMF will be there. But second thing what he has added, the actually the production of EMF is directly proportional to the rate of change of magnetic flux. If the flux is changing very speed, in a very high speed, so the EMF generated will be very greater in the magnitude wise. If the rate of change of magnetic flux is very slow, means the flux is changing very slowly, so the EMF generated will be magnitude wise very low. So means I want to change the proportionality sign into equal to sign. So what I will keep a k constant which is equals to 1 in all the system of units. So in that case what I can write, magnitude wise, whatever I am talking right now is about the magnitude wise, means E average, the EMF induced average value will be equals to minus d phi minus delta phi by delta t. Means else if I talk about the instantaneous, means the EMF induced at any particular instant of time. So that can be find out with the derivation of, or differentiation of, sorry, derivation I should have not used, differentiation of magnetic flux with respect to time. If you will do this thing, so you will get the EMF induced value at any instant of time. So since we are talking about only the magnitude, as I told you, the formula can also be written as E magnitude, E modulus is equals to d phi by dt modulus. If we talk about the direction also, now something is introduced here. If we will talk about the direction also, then E is equals to minus d phi by dt. Now, from where this minus sign is coming? Minus sign is taken because an induced EMF always opposes any change in magnetic flux associated with the circuit. Always remember this concept, the minus concept was actually given by the Lenz, okay? And what he told कि जिस वजह से EMF produced हो रहा है circuit में, okay? And if suppose the EMF is produced in the increase in the magnetic field strength, okay? So what the direction, in which direction this EMF will be, in which direction the EMF will be, the EMF will be always opposite to that direction. Means suppose the magnetic field is increasing in the east direction, so our EMF will be induced in the west direction. So whatsoever the quantity is producing it, it will always oppose that quantity. जिस वजह से ये प्रोड्यूस होता है EMF, ये हमेशा उसे अपोज करता है. So this is all about the direction of the EMF, okay, which was introduced by the Lenz. We will study about the Lenz concept and all detail in the next very videos, but let us complete this video for today. Suppose if there are n number of turns, let us assume the coil which we have taken is having not only a single turn, it is having n number of turns. Then what will you do? Easy, what we will do, we will multiply the number of turns with our formula. So E will become minus n into d phi by dt. But if suppose resistance is also there, if the resistance of the coil is R ohm, means the coil which we are using is having its own resistance as well. So then what we will do, how we will find out the induced current? So I average can be find out with the using the Ohm's law, V upon R. So in place of V, we will use induced EMF average value upon the resistance. So the formula will look like this: 1 upon R multiplied by delta phi upon delta T, which is total change in flux upon total time taken. And if I will talk about the instantaneous value, so E instantaneous upon R is equals to d phi by dt multiplied by 1 upon R. So d phi by dt will give you the rate of change of magnetic flux with respect to a particular unit of time. Okay, so this is all about the introduction of the chapter. In the next very videos, we will study the topic, each and every topic in detail. Thank you.